Good morning, dear children. Now we will move to our third chapter, force and pressure. Okay. So earlier you have learned about force. What is force? A push or a pull can be called as a force, isn't it? And what do you mean by push and a pull, or a push or a pull? Push means by applying force, or when you touch an object, that object should move away from you, isn't it? So if the object moves away from you, you can call it as push. And if the object comes closer to you, you can call it as pull. And a push or a pull can be called as force, isn't it? That is what we learned. So if an object moves away from us, that is push. If it comes towards us, that is pull. And a push or pull can be called as force. Now, actually this chalk, I hope it is visible for you. It is free to move, isn't it? This chalk is free to move. Now it is in the state of rest. And by applying force, what happened? It moved. So, here this chalk is free to move, and when I applied force, it moved in a straight line. Okay. So actually this is known as translational motion or straight line motion. By applying force on a body which is free to move, translational motion takes place. That is, the body moves in a straight line. Okay. Now, instead of that, I am taking a bottle now. And here I have the lid of the bottle. Okay. Now, I am applying force on this lid. Is this lid free to move? No. This lid is actually fixed on this bottle, isn't it? So, see, this lid is fixed on this bottle, and when I apply force on it, it actually undergoes a rotational motion. In the previous case, when I showed you with the chalk, by applying force, the chalk moved in a straight line. That is, it has undergone translational or straight line motion because the chalk was free to move. But when you consider this, the lid of this bottle or cap of this bottle, it is actually fixed on this. So by applying force, what is produced there? Just a turning effect is produced, isn't it? That is, it has undergone rotational motion. So here also I have applied force, but the only difference is, in the previous case chalk was free to move, but in this case this object is fixed. At that time, by applying force, a turning effect is produced. And this turning effect of force can be called as torque or moment of force. Torque or moment of force. Okay. So, by applying force on a body which is fixed at a point, turning effect will be produced, or rotational motion is produced there, and that effect of force is known as torque or moment of force. Okay. Another simple example, in the case of your doors or windows. Actually, the doors are fixed on the hinges, isn't it? Doors are fixed on the hinges and the doors are not free to move. If you apply force on the door, what happens? Will it move freely? No. Actually, the door is fixed on a point and it is not free to move. So, when you apply force on a door, it undergoes rotational motion or a turning effect. The door just turns, isn't it? So, a turning effect is produced there, and this turning effect of force can be called as torque or moment of force. Okay. So, is it clear? We have started with force. A push or a pull can be called as force. Push means the object will move away from us. Pull means it will come closer to us. Then When you are applying force on a body which is free to move, what happens? The body moves in a straight line and we'll call it as translational or straight line motion. But if the body is fixed at a point, by applying force, a turning effect is produced. And this turning effect of force is known as torque or moment of force. So many examples are there for this. I told you about the door, then the cap of a bottle, steering wheel. Actually, steering wheel is fixed there, isn't it? So by applying force, when you are driving, you will be applying force on the steering wheel, and by applying force, a turning effect is produced there. Then again, in the case of closing or opening the tap to take water, you will be turning it, isn't it? So these things are, in all these cases, you are exerting force, and due to this force, a turning effect is produced. That means it causes torque. Okay, torque or moment of force. Torque is also known as moment of force. This torque is represented by a Greek letter tau. It's read as tau. Okay, Greek letter tau is used in order to represent torque. Force, normal force is represented by capital F, but torque is represented by the Greek letter tau. Clear? Now, the next thing, we need the equation to calculate torque. So already I told you the turning effect produced by force is known as torque or moment of force. Now, the equation for tau is force into the distance, okay, perpendicular distance between point of application of force, and the axis, fixed axis or axis of rotation. Okay, so torque is given by the equation tau is equal to force, or we'll say it as magnitude of force. Do you know what is magnitude? Magnitude means it is the numerical value. Okay, if I say that force, do you know what is the unit for force? What is the exact unit for force? Force is measured in Newton, isn't it? Named after the scientist Sir Isaac Newton. So its unit, when I write the symbol for unit, I should use capital letter since it is named after a scientist. So capital N stands for Newton, or the symbol of unit for force. Now, here torque is given by the equation magnitude of force into perpendicular distance. So, magnitude means it is the numerical value. Suppose I have exerted a force of 10 Newton on this. Okay. So, in that, so you can write the force as F is equal to 10 Newton. In this, F is the physical quantity. What do you mean by physical quantity? Quantities which can be measured. So, F is the physical quantity. This 10 is known as the magnitude. Okay. So, magnitude means it is numerical value. Numerical value is known as magnitude. So, force is equal to 10 Newton. In this, force is the physical quantity which is represented using its magnitude and unit. All the physical quantities are represented using its magnitude and unit. So, the magnitude is 10 and the unit is Newton. Okay. So, that is another important thing what you should remember. Quantities which can be measured. All the quantities around us are not measurable. The quantities which can be measured are called physical quantities, and a physical quantity will be always expressed in terms of its magnitude and unit. Magnitude means that is a numerical value. Unit, you know what it is. Okay. So when you write the equations, in most of the cases, you can say, you can see it as magnitude of. So that means that numerical value. Okay, that is known as magnitude. So here also you can see in your textbook that moment of force or torque is equal to magnitude of force into perpendicular distance between the point of application of force and the axis of rotation, or where that object is fixed. Okay, so that is the equation in order to calculate moment of force. Now we will come to that equation, then it will be more clear for you. Torque or moment of force, from the equation it is clear that torque or moment of force depends on two factors. Which are those two factors? Magnitude of the force, then perpendicular distance. Okay, so I have kept the chalk here. With chalk I cannot say, because chalk, when you apply force on chalk, it produces translational motion because it is not fixed at a point. Okay, so here I have the bottle, or better I'll take a tester. Okay, tester or a screwdriver you can consider. So what is the use of a screwdriver? It is used in order to tighten or loosen a screw, isn't it? So I have a tester, you can consider it as a screwdriver. Now it is used in order to tighten or loosen a screw. Here, if I want to tighten or loosen a screw, if I apply for only a less amount of force, what about the turning effect produced here? By applying a small amount of force, if I exert only small force on this screwdriver, only a small turning effect will be produced, isn't it? If I am exerting more force, what happens? More turning effect will be produced. So, turning effect of force is known as torque or moment of force. When you increase the force, what happens to the turning effect or moment of force? It also increases. Okay. So you can say that torque depends on the magnitude of the force. If you are applying 5 Newton of force, only a small turning effect will be produced. If you are exerting more amount of force, more turning effect. Or in the case of a car, when you are driving, if you want to turn if you are just turning, or if only a small force is exerted on the steering, only a small movement will be there, or a small turning effect will be produced there in the steering. But if you are applying more force, what happens? More turning effect will be produced, isn't it? So, by increasing the force, you can increase the torque produced there. Now, the next one is perpendicular distance. Okay. So, in order to tighten or loosen a screw, we need only this tip portion, isn't it? Only the tip portion of the screwdriver is needed. But when you check, for most of the screwdrivers, you will be having a long arm. Have you noticed that? Here, since it is a tester, it is short. But usually when you take a screwdriver, usually it has a long arm. So have you noticed that? For us, in order to tighten or loosen a screw, we need only this tip portion. Then why should it be this much longer? Do you know what is the reason? If you are tightening or loosening a screw by holding the screwdriver near the tip, you have to apply more force. It is difficult. But if you hold here, that is at a distance from the tip, you can easily tighten or loosen the screw. Have you noticed that? You can check, okay? If you are tightening or loosening a screw, and if you hold it near the tip of the screwdriver, it will take time and it is difficult. But instead of that, if you are holding at the head of the screwdriver, you can turn it easily. Now, another one. We have doors in our houses, isn't it? And where is the handle of the door placed? In all the doors, the handle will be placed at a maximum distance from the hinges, isn't it? Do you know what are hinges? Vijagiri. and there this door will be fixed there, isn't it? So in all the doors, the handle will be placed at a maximum distance from the hinges. Okay, so let this be the axis of rotation, and here we have fixed the door. Okay, let this be our door. It's fixed on this. Okay, where are we keeping the handle? Is it here or here? The handle will be always placed at a maximum distance from the hinges. Can you tell me what is the reason there? What is the reason? Or if you can just try open a door in your house by applying force near the hinges. You can just try it now itself using your hand. We don't want any other object. Just move to a door, push it. Push it at a portion closer to the hinges as well as near the handle, that is away from the hinges. In which case you have to apply more force. You have to apply more force near the hinges, but here if you just touch, the door gets opened. But here you should apply more force. Okay, so do you know what is the reason? Did you try that? Now itself, you can just pause the video and you can try that. If you want to open or close a door, and if you are applying force closer to the hinges, you should exert more force. But if it is away from the hinges, by just touching, it gets opened or closed. So, did you see the result? Did you check that? So, what is the reason there? Here, the doors are actually fixed on the hinges. That means it is not free to move, isn't it? So, by applying force, a turning effect is produced. Turning effect or moment of force depends on two factors: the magnitude of the force as well as perpendicular distance between the axis of rotation and point of application of force. If the distance increases, then the turning effect produced also increases. Okay, so that is a very, very important point. By increasing the distance between the axis of rotation, that means where it is fixed, and the point where you are applying force. So when you increase this distance, what happens? You have to apply only a small amount of force, and with that a large turning effect can be produced. Okay, so it's a very, very important point, and many examples are there in our day-to-day life under this. Okay, so I told you about the screwdriver. So when you take a screwdriver, for most of the screwdrivers will be having a long handle. So if you hold it near the head of the screwdriver, you can easily tighten or loosen the nut, because if the distance between the point of application of force and axis of rotation increases, maximum turning effect can be produced by applying small amount of force. Okay. Then the next one I told you in the case of steering wheel, same thing we have. Then in the case of a what again I can say, in the case of a spanner, in all these cases, in the case of spanner, we need just that opening part in order to tighten or loosen the screw. But usually these spanners or wrench, spanner or wrench means many blocks will be there, no, many spaces will be there to tighten or loosen screws of different sizes when you are taking a wrench. But if it is a spanner, only two portions will be there. So you can open only screws of that particular size. But in the case of a wrench, screws of different sizes can be tightened or loosened. So what you have to remember here, in all these cases a long handle is there, because if the distance between the perpendicular distance between the axis of rotation and the point of application of force increases, maximum turning effect can be produced by applying a small amount of force. Okay. So I hope it is clear for you with these examples. So we have discussed about moment of force or torque. The turning effect produced by force is known as moment of force or torque. It depends on two factors. Which are those two factors? Magnitude of force. That means if you are applying more force, more turning effect will be produced. If the force applied is less, only less turning effect will be produced. Then the second one is the perpendicular distance between the axis of rotation and point of application of force. So when you increase this distance, then the turning effect produced will be more. Okay. So many examples are there in our day-to-day life which can be explained on the basis of moment of force or torque. Now we need the unit. So I told you torque is given by force into distance, isn't it? What is the SI unit for force? It is Newton. What is the SI unit for distance? Meter. So Newton meter is the SI unit for moment of force or torque. Okay. Moment of force or torque is expressed using the unit Newton meter. Then how can you define this Newton meter? If 1 Newton force acts on a body to produce a displacement of 1 meter on a body, then the torque will be 1 Newton meter. Okay, I'll repeat. Usually for the board exam, they won't ask you to write the definition for a physical quantity. They will ask the definition for units. Okay, so in that case, usually what we'll do is we will write the equation. Okay, write the equation for that physical quantity, then you make the definition out of it. So if you want to get torque as 1 Newton meter, the force should be 1 Newton and the unit should be 1 meter. Sorry, if distance should be 1 meter, isn't it? If you want to get the moment of force as 1 Newton meter, force should be 1 Newton and the distance should be 1 meter. So from this we can make a definition for 1 Newton meter. 1 Newton meter is the torque produced if 1 Newton of force acts on a body to move it through a distance of 1 meter. If 1 Newton of force acts on a body to move it through 1 meter, then the turning effect produced there will be 1 Newton meter. This is how we will define the unit. Okay. So this is very important. What is Newton meter? So hope it is clear for you. We have discussed a new term, torque or moment of force, its equation, then the factors on which torque depends, then its unit. So torque depends on two factors, how much force you are applying plus the distance between the axis and the point of application. If the distance is more turning effect can be produced there. Okay. So thank you children.